Hi Barry.
Hi Marge.
Just wondered if you could help me.
Yeah, absolutely.
Week 3 exercise, I just can't begin to sort of work out how to do it. Remember what it said? I'm looking for a 5-digit number containing each of the digits 1, 2, 3, 4 precisely once for each. N equals 1, 2, 3, 4, 5. The first n digits of this number, read as an n-digit integer, must be divisible by n without remainder. Can you find such a number? So,
Okay.
I just can't think how to do it.
Okay, so what have you tried so far?
I've tried this.
Okay, let's have a
Well, I
look.
kind of trying to get my head around it by thinking what the question means. I hope I've got that right. So basically, the first digit has to be divisible by 1.
Yeah.
First digit is divisible by 2. And
as
down
a two-digit
the list.
number.
As a two-digit number. And so on down the list. But I just thought that means 120 different calculations randomly, pretty random. And I'm sure that maths says there must be an easier way to do that.
Okay, I mean,
I just have really struggled with it.
Sure. I mean, good. You're right in that there are 120 possibilities, so that's good for working that out. That's 5 factorial possible choices for how you can arrange these digits into form a 5-digit number. And you've written down the important conditions here. So we just need to start to unwrap these and understand what each of these conditions mean. So let's take them in turn. Let's start with this last one here and see if it tells us anything about our number. So the first 5 digits, read as a 5-digit number, are divisible by 5. So what do you know about numbers divisible by 5?
They're 5s and 10s. Or 5s and things with a naught at the end.
Right, so they end in 0 or 5.
Yeah.
Okay, good. Now what digits do we have available to us?
Okay,
we haven't
got naught, have we? So we've only got 5.
Only got 5. So
okay.
Now you know what number it ends in, what digit it ends with.
Yeah, so it all must end in a 5.
Absolutely.
Okay, I've got it.
Great. Okay, so maybe we make a note of that, just so we remember that.
Are we going to work through the rest of them?
Absolutely.
Well, what helps me is to see it sort of visually.
Okay.
What if we do a table with 5 numbers? I don't know how many numbers there could be. Maybe we'll have to go on to the other side. I don't know. But
okay.
We know it ends in a 5. I suppose, can we start with 1, 2, 3, 4, 5?
Well, it would be a guess, yeah.
Just so that we know what numbers we're dealing with, and that's kind of how I see it.
Okay.
Okay,
Great.
So we know that all these are going to be 5s. That's a nice thing to sort of fill in, isn't it?
Great. Good. So that's come from this sentence here.
Yeah. So we've done that one.
That's right. Does that first one help us at all?
Well, not really, does it? Because it could be 1, 2, 3 or 4.
Okay. Why can't it be 5?
Because 5's here.
Right. We've already used up our 5. Good.
Yeah.
Okay. How about the second sentence? The first 2 digits is a 2-digit number, is divisible by 2.
Okay.
What do you know about such numbers?
They're 2s, 4s, 6, 8, 10.
Okay. Good.
Yeah.
So what numbers do they end in?
On our list, I guess just 2 and 4.
Right, okay, so you said they could end in a 2, 4, 6, 8 or 10, but we've only got 2 or 4 available.
Okay.
Okay, great. So we know that what do we know? You tell me.
We know it must be a 2 or a 4.
What must be 2 or 4?
The second digit.
Good, yes, absolutely.
So 2 or 4.
Okay, great. We'll just leave that one for a minute, but we'll come back to it. Let's have a look at this one, which is much more similar to the one we've just done.
Okay.
The first 4 digits, read as a 4-digit number, is divisible by 4. What do you know about those numbers?
They end in 4, 8, 12. I suppose that means 2.
Yeah, good.
16.
Okay, so it can end in a 6.
20.
And 20 ends in a 0.
0.
So we've gone through all the even numbers again.
Yeah.
Yeah, okay, so which ones are available to us?
Not the noughts or the 6s or the 8s, so I suppose it's 2 and 4.
It's again 2 and 4, okay.
So we could put 4 and 2.
Okay, why did you not put a 2 there?
Because we've already used it up.
Okay, great. Good, so now we know 3 of our digits of our 5-digit number.
Wow.
Then there are 2 possibilities so far. Now we've got what left?
1s and 3s.
1s and 3s. So how could we arrange those within our numbers?
Well, we could put... Well, we've got 1 and 3 there already.
Okay.
So we could put 3 and 1.
Good.
Yeah.
Yeah, great. And how about this one? We still need to put 1s and 3s in that one.
Oh, right, okay. So that could be 1 and 3.
Yeah.
Or that could be 3 and 1. Yeah?
Yeah.
Like that?
Fantastic. That's right. And so now we've reduced our 120 possibilities just by a bit of analysis of these statements down to 4 possibilities.
And that's it, isn't it? We've used them all up. We used all the combinations up.
We've shown that the other combinations are not possible.
So we don't need to worry about these.
Okay. So do we know that these satisfy the conditions of our problem?
Okay, I don't know that without going back, do I?
Okay, so we're going to go work through our conditions.
Okay. Well, we kind of know. We already know 2. These are all, these numbers end in a 2 and a 4, so they must be okay.
Good.
3s, I don't know without working it out.
So you're looking at 123. So do you know a way of checking whether that number is divisible by 3?
Well, going back to my secondary maths, I know that if anything ending in a 3, if you add the digits up, isn't that right? And it's divisible by 3, then the whole number will be divisible by 3.
Absolutely, yeah.
So this one I'm adding up the first of the 3 numbers, so that's a 6, so that will definitely work.
Good.
That's a 6, so that will work. That's an 8, so that's not going to work.
Okay.
And that's an 8, so that's not going to work.
Okay, great. So
we're down to 2 numbers.
Down to 2. Fantastic.
Wow. Out of 120. Fantastic.
Okay, so now this statement's the next one to worry about.
Okay, so 4s. So kind of, we don't know that without doing a bit of working out, I think. So 1200, if that's divisible by 4.
Yeah.
But 34 isn't.
Okay, and that's a great way of thinking about it. Yeah, good.
Yeah.
Good.
3200 is divisible by 4.
Yeah.
But 14 isn't.
Okay.
So
that's right.
None of them then, is that right?
Well,
you did say, it does say, can you find such a number? It doesn't say, give me a number. So
that's right.
That is an option, isn't it?
That's an option, yeah.
Okay. So the answer's no.
The answer's no, absolutely. Well done. That's fantastic.
Oh, right. That was just, much helpful having all that logic applied to it. That's really good.
Good. Just so you're sure, and I'm sure that you understand this, can you just take me back through the steps? What did we do in order to show that there were no solutions to that problem?
We looked at each of the possibilities in a consistent way.
Okay, so but you did something. You came with some prior knowledge from prior working. What had you done first?
I'd worked out really what the question meant in
Okay.
terms of what I had to work out.
Good, yeah, that's
I
right.
worked out what conditions had to be satisfied, really.
Yeah, you worked out the conditions in the question. That's great.
Yeah.
And then what did we do?
Well, then I went and checked that actually the unique numbers that we'd come up with satisfied the conditions of the problem.
Okay, how did we get down to our list of numbers there?
We eliminated all the other possibilities.
Okay, so one by one we worked our way through these statements. We got rid of a lot of possibilities, and that left us with a few we needed to check, and then we went back and made sure that either they satisfied the conditions or they didn't, and we found that none of them did. Okay.
Okay. Oh, great. Thanks very much, Barry.
It's a pleasure.